Hello, welcome to ANS Solver. This is the seventh question of the paper. So they have given us an equation which is y equals to sine of x plus 1 over 3 pi multiplied by cos x. This has two stationary points in the interval and I need to find the dy by dx. So basically for the dy by dx, I know I need to use something called as the product rule, because a variable is multiplied by another variable here. So I take my u as sine of x plus 1 over 3 pi. Okay, and I take my v as cos x. So basically the u dash is the differentiation of sine x plus 1 over 3 pi, which is cos x plus 1 over 3 pi multiplied by the differentiation of x plus 1 over 3 pi, which is 1. And my v dash is simply minus sine x. So now what I can do is I can simply use my formula, which states that u into v dash plus v into u dash. So now I can simply write this as minus sine x plus 1 by 3 pi plus cos x, okay, or you can say plus cos x plus 1 by 3 pi, okay, into cos x. So now I get my dy by dx basically as, I can write this as cos x plus 1 over 3 pi minus sin x plus 1 over 3 pi. Okay, so this is my dy by dx. Okay, now by considering the formula for cos a plus b, show that at the stationary point on the curve this is equal to 0. Now if you see cos a plus b, the formula is simply cos a cos b minus sin a sin b. And if you notice here, this is in the same form where a is my x and b is x plus 1 upon 3 pi. So I can simply write this as cos of x plus 1 over 3 pi, which can be written as cos of 2x plus 1 over 3 pi. Okay, so now what I can simply do is I need to show, because I need the stationary point. I know in the stationary point my gradient or my dy by dx is equal to 0. So I can simply equate this to 0. Okay, so this is what I needed to prove. Now, yes, so this is the third part of the question. So I need the exact x coordinates of the stationary point. So I derived this equation from part 2, correct? So now I know my domain which they have given me is from 0 to pi, correct? This is what I know. Now what I simply need to do is I need the cos of a positive number. Okay, so what I'll do is I'll do 2x plus 1 over 3 pi is equal to, remember your trigo, here there's a, s, t, c. Cos is positive in the first quadrant and the last quadrant. So now do cos inverse of 0 in the radian mode. So you get 1 over 2 pi. But now for the fourth quadrant, I do 2 pi minus 1 over 2 pi. Correct? That's how we calculate. So 2 minus 1 over 2 will give me 3 over 2 pi. So now what I do is I do 2x equals to, I do 1 over 2 minus 1 over 3, which will give me 1 over 6 pi, comma, I'll do 3 over 2 minus 1 over 3, which will give me 7 by 6 pi. Now what I'll do is I can say my x is basically equal to, I can say it's equal to 1 over 6, okay, divided by 2, which gives me 1 over 12 pi, comma, I get 7 by 12 pi. Now if you see, pi is 3.14 and 7 by 12 pi, if you try to get in decimals, is 1.83. That means both of these values are lying in my range and these are my x coordinates of the stationary points.